Good afternoon. Wow. This must have been like a dead stage. Like, has there anybody been here before me? Nobody's warmed you up a little bit? Is there caffeine around? I know there's coffee stations just outside the door, and there's like Cokes and other things in the lobby there. Yeah? All right, let's try this one more time. Good afternoon. Good afternoon. All right, that's a little bit better. Okay, so my name is Josh Holmes. I'm an architect on the Partner Catalyst team, which is inside the Technical Evangelism Development team, which is inside of DX, which is inside of Microsoft. Is that a long enough title? I can make it longer. So, all right. So, what I want to do is I want to start with a story about any Icelandics in the room? One? Help me with the pronunciation of this. Leader. 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 And his son's name is Siggy. It's not Siggy, it's Sigurður something or other that I can't pronounce either. He goes by Siggy. Leaderson. Okay, thank you very much. So he is a father. In fact, he's a father of a good friend of mine. He's a grandfather of my friend's children. He's a captain, he's a fisherman. He actually owned his whole fishing boat, and at the age of 32, he got diagnosed as a diabetic. Okay, and that all of a sudden put an interesting stop on his life, because he actually was diagnosed with type 1 diabetes, which that's actually quite late to be diagnosed with type 1 diabetes. Type 1 is usually diagnosed before the age of 10. Sometimes it is escaped until the age of 30, but this is kind of the second round here when he was diagnosed. But he is insulin dependent, and it really made an interesting and strong impact on his life. So one of the things that they started talking about, since he was the captain of the fishing boat and he had 10 lives that were dependent upon him, is that if he double dosed, he could potentially go into a coma and go unconscious. There's so many possible things that could go wrong with diabetes, and he needed to be in a position where other lives were not depending upon him being awake. And so they asked him to give up his livelihood and change his life entirely to continue with his diabetes care. Does that sound like a winning plan? Not so much, okay? Especially since he's from Iceland, and he actually lives not on the main island, but on a small island off to the south of the island. I forget the name of it. What's that? That's the one, yes. So he lives in a small island where he said, because I can't pronounce that one either. I'm working on all these Icelandic pronunciations, but putting it on tape is a little different. But he lives out on a small island where you travel to the south tip of the island, and then you get on a ferry boat and travel out there. But there's just not a lot of jobs other than being a fisherman. And being the captain, he was in a prominent place with a good amount of income. But he was really sick and started to, it started having these profound impacts on his life. And so he carries all of these medical supplies with him. And his son, Siggy, started a company called Metalink. And Metalink is trying to solve his father's problem, okay? And so what Metalink does is, this is a smart glucometer and a smart pen. And so what you do is you take your blood sugar, and then it reports that in. It runs machine learning algorithms against it to see, what have you eaten recently? What have you exercised recently? How much insulin do you actually need? And then weighs that out of the pen to the microgram, and then it dramatically reduces the possibility for double dosing, which means that he can go back to being a captain on his fishing boat, and he can continue his life. Okay. In addition, they found all kinds of additional and interesting things that they could do once they started capturing all this data on this smart device, because this device is actually connected. And it starts sending the reports from his readings back into a thing that they are calling CloudLink. And so he's able to feed the data from his MyFitnessPal and the other places where he's capturing what he's eating, into Mondo where he's capturing what he's doing from an exercise perspective, and the glucometer. They're capturing all that data and actually able to do a historical, this is when you eat this, when you exercise this way, etc. This is how it affects not just diabetics in general, but you in particular. And then we can look at trends across a lot of diabetics to help figure out what it looks like across all diabetics. And also, we're able to feed that into his doctor's office. And so when he walks into his doctor's office, it's not, tell me 3 readings that you've had in the last month, 1 right before breakfast, 1 2 hours after lunch, and 1 in the evening. That's the typical, right? And so you now have to remember these, or you've written them down, or you're bringing out your device and scrolling through the logs and picking some. Instead, we can actually trend this across time and actually feed this directly into the doctor's office. So, number of challenges here. One is, how do we connect the device itself? Second of all, once we get the data into Azure, how do we actually store that in a secure way, and then how do we run machine learning against that and actually start doing the predictions and that type of stuff? So, groundwork, questions, thoughts so far? Everybody want to go save this guy's life? Yes. Good. The rest of you can, there's another stage somewhere else. It's as nice as I can be right now. All right, so step 1 is IoT. So, how many people have played with Azure IoT Hub? Handful of people, all right. In fact, a good portion of people, very good. So I won't spend a lot of time here. So we've got a number of different ways to connect to the device, to IoT Hub. They're actually running a Linux variant on their little device. Oops, whoa. It went away, hang on. I know it's not the optimal resolution. This is the resolution that they told me to be at. All right. So on their device, this device right there, they're actually running a Linux variant. I actually forget which one now. And so we're actually, we wrote most of the code in C to talk back to the gateway there. So, but the cloud gateway itself, we've got a lot of different ways to connect to it. We've got field gateways for out in the fields. We didn't need that in this case. You can do field gateways and protocol adapters in case you're talking a funky protocol. And so a funky protocol could be the protocol that it speaks out of the gate or out of the box is a protocol called AMQP. And so if you're using anything else, you'll need some type of a protocol adapter. We've written the one for MQTT. We're in process of writing the one for CoAP. We're looking at other protocols, but if you're writing your own protocol, then you'll have to end up writing a protocol adapter. We actually got to use the top line there, so we're talking AMQP directly in from the Linux device itself. Then there's a bunch of other stuff on the back end. So we did a little bit of hot path analytics, looking at stream analytics. I'm not going to dive into that too much right here because I don't have a tremendous amount of time. But what we're going to spend a little bit more time on is the Azure machine learning side of this, okay? And then we can plug into a number of different other services. They're actually using notification hubs to send out notifications of when there's a low blood sugar, high blood sugar event that is outside of the manageable range. They're actually sending text messages to the doctor and to the immediate family members as well. Okay, so sending data to IoT Hub. I thought about bringing it up and actually doing some code at this point in time and actually writing a bunch of code. It's actually fairly boring to A, watch me type, and B, the code here is pretty box standard and just kind of works. So we got a function here, send message. We're passing in the handle to the IoT Hub client, a buffer of the characters that we want to send, and then the measurement itself. So what is the glucose measurement? We're actually pulling the date, time, and other things directly off the server because we know what those are right there. So we have a my laser's too weak to show up on the screen there. Let's see what else is interesting in this. So sending the message async, and then we get back a call to see, did it actually send, did it not send, etc. And then we have to, since we're in C++, clean up all of that code. So the more interesting part of this, beyond the consuming or capturing all the data, is actually on the ML side of things. Okay, so step one, talking about the ML continuum at Microsoft, okay? And so we've actually got a lot of stuff that we do here at Microsoft. And so this is my take on it. It's not Harry's take on it. Harry Shum yesterday has this is my take on some of the things that he says. But we start off with the consumer side of things, where we've got Cortana, Bing, Word, the products that you guys are already using, a lot of them anyway. And we're already doing a ton of machine learning behind the scenes on those things. And we have been doing machine learning behind the scenes on those things for quite a while, right? And so that's on the consumer side. You guys just get to leverage it, right? Then the next bit is where we get into where we have a bunch of developers who are not machine learning experts. How many people would consider themselves machine learning experts? Nobody. Okay, very good. Michael Lanzetta's over there. He's a machine learning expert. He's on my team. So he's going to call bullshit on a lot of what I say next. He nodded. So so step one is we've got a bunch of things, and you saw a bunch of these being exhibited yesterday in Harry's keynote, called cognitive services. And these are things where we can simply leverage the algorithms and the work that somebody else has already done, and we can feed it images and we can do customization, right? So we can give it, here are some phrases, here's some lingo, here's some images that we want you to recognize, but the pipeline is already set up. We give very clear instructions on here's what you need to do for the data, and so on and so forth. And then you can just call it API, and it will return an answer or not, right? And so for developers, this is a real easy way to start leveraging a lot of machine learning. And there's a bunch of different cognitive services. Does anybody remember the exact number? It was like high 20s. 29, I think Harry said yesterday. Nobody's arguing with me on that, so I'm going to go with that for now. But I'm willing to be wrong on the exact number. But it was high 20s cognitive services, and these include image detection, facial recognition, LUIS, so the language understanding and intent service, a bunch of them. And we're using these in a bunch of different interesting ways. So how many people caught Jason Fox's talk yesterday? All right. So one of the things that we're using it for is like the facial recognition one. We're actually working with refugees that are coming into the Red Cross refugee camps. And one of the common scenarios is a parent will show up and have a picture of their son and say, I can't find my son. That's a heartbreaking moment, right? Because the Red Cross, they take pictures of everybody who comes in, but it's like, here's 100,000, 200,000 people that we've brought in the last handful of months. Good luck. It's like finding a face in the Super Bowl. And so what we're able to do is we take that picture of the sun and we run it against the pictures that we've already taken and have already uploaded, and we're able to pull back and say, here's the 20, 30, 40 that look like your son, and actually make that a feasible task to actually go through that list of people. But we're using cognitive services to do that. And so these are incredibly useful and incredibly powerful. Right. The next stage, and this is actually where we're going to talk about machine learning for Metalink, is where we've got regressions, binary classifiers, a bunch of stuff that is in the traditional machine learning space. And for the things that it does it pretty well. Then there's a pretty significant drop off between that and the next step, which is deep learning, where we've got CNTK, TLC, we can run TensorFlow, and there's a bunch of other options for deep learning, which is a great conversation for Michael Lanzetta over there as to that guy right there, who waved briefly, not enough people were looking, so there he is, yeah. One of the coolest shirts here, just saying. Anyways, so machine learning, we're able to do quite a bit through the Azure Machine Learning Studio. But the interesting part, and this is the part that a lot of people don't grok completely about data science and about machine learning, is that the tremendous percentage of time is actually spent, A, understanding what the question is, and then B, making sure that you've got the data and that data, number 3, is in the right shape in order to ask the question in the first place, okay? And so diabetes measurements, we've got a bunch of those, great. But then we've got to go through a bunch of different transforms in order to get to the point where we can actually stand it up and do a predictive service, right? But that data, step 1, we've got the data. Step 2, we have to start transforming all of that. And so most of the code that we actually ended up writing was actually in this, let me get out of this. Where are we at? Most of the code that we ended up writing was in this create time series data, right? And create time series data, step 1 is we're taking in the input CVS, and then we're going to output it. And we start with how big is our trigger window? So, because what we wanted to do was actually look at not just an individual reading, but actually look at time series data across time, because it's not the static reading that we care about, it's the series of events leading up to a hypoglycemic event, right? And so, how big of a window do we want? And then there's quite a bit of code, and I'm not going to drain all of this code, but we're grabbing the timestamps, and we're going through each of these entries and starting to look at the timestamps, splitting them. Long story short, creating a time series set of data, and our data goes from a simple Excel spreadsheet to looking a little more like this, where we actually have time windows. And each one of these windows, we're able to start running our algorithms against and compare this in a sliding window with the newest entries, our trigger window, and then previous data, so we can actually see how these people are trending over time. Okay, all right. And then the next bit, kicking back over to here. So now that we've created the time series data, the next bit is to actually dive into the code itself. But step 1, we're actually going to go in and look at our look at our data, and we're going to split the data into positives and negatives. Was there a hypoglycemic event? Was there not a hypoglycemic event? We're going to go through and remove duplicate rows. We're splitting the data. We're rejoining the data with external data sources, adding more rows to get to the final training set. And so, again, most of the work was actually in getting the data into a shape that we could actually train with it. Then, once we actually train, so then we've got a number of different R scripts. But what we actually ended up using was a boosted two-class boosted decision tree, and doing our work that way. So trained the model in 4 different ways, okay, and then compared the results of those 4 different ones. So we have some R scripts that are feeding data in. We have the two-class boosted decision tree. We've got more R scripts over here. I have 42 seconds left. So if you want, feel free to grab me and we'll actually go through this in a lot more detail. But really what I wanted to get across was the part of data science and machine learning that a lot of people don't seem to get is getting the data into the right shape in the first place. Is really that's where a lot of the heavy lifting engineering goes. And then the other bit that I thought was really interesting that I learned out of this was that we can't ask, what will the glucose value be in 3 hours, right? So let me ask you this. Are the brakes going to go out in your car? The answer is yes, someday. What's the likelihood that your brakes are going to go out in the next 24 hours? Well, if you've got decent pads on them and you've got a decent sized rotor, likelihood is pretty low, right? Can I predict it 100%? No. Can I predict it, definitively yes? No. It's all probabilistic. And so what I can really ask is, what is the chance that a hypoglycemic event occurs within the next 24 hours? That's the question I can ask versus the definitive, what will the exact value be? Once we've determined that, then it's all about getting that data into shape. And the ML part of it, of this particular project, was actually pretty small. It was actually all of the data munging and ETL work that was actually the problem. So, ton of different references. This site will be will be on the website. And my name's Josh Holmes. You can find me on Twitter. You can find me on joshholmes.com, and I'll be posting this deck on joshholmes.com as well. So with that, thank you very much.